Only in hexagons. Now, our apothem is 4 square roots of 3. So we're going to plug it into our formula. Area is equal to 1/2 times apothem times perimeter. I want you to write it first. Just like that. I want you to write it first. Then you can start plugging in stuff and simplifying it. Our apothem is 4 square roots of 3. Our perimeter is 48. Multiply that by 6, because there's 6 of those 8-unit long sides. So 8 times 6 is 48. Plug that in. And then we got to simplify this. I need my answer to be exact. It's going to have a square root of 3 in it. I don't want you to type the square root of 3 into your calculator and spit out some decimal. So this is going to be 96 square roots of 3 in the end. Yep. 96 square roots of 3 units squared. I need to see that. Units squared. Okay. Now sometimes what's going to happen is you got to use trigonometry. Sometimes what happens is you got to use trigonometry. So let's take a gander at number 16 together. Take a look at number 16. I want you to determine the measure of the central angle created by 2 consecutive radii. Number 16. How many sides we got? 7. What else are we given? Radius is 5 units. So this is a whole lot like the problem we just got done, number 14. A whole lot like that. What's the measure of the central angle created by 2 consecutive radii? Let's go ahead and round to the nearest tenth. Round to the nearest tenth is 51.4. Fantastic. Okay. The next step, after finding the measure of the central angle, is introduce that apothem. The apothem does 2 things. It bisects that side, and it also bisects that vertex angle, that central angle that we just got done finding. So then we turn our focus to this right triangle that's being created by apothem, half of the side length, and radius. We were given the radius length. So I'm going to erase R, or just never write it, and put what I'm given. It is 5 units long. You can always find one angle in this right triangle. It's always the angle created by the apothem and the radius. What is the measure of this right triangle's top angle right now? 25.7 degrees. Okay. We need to solve for half of the side length. Then we're going to double it to figure out what one side length is. Then we're going to have to multiply it by 7 to get the perimeter. After we do all that, we're then going to have to solve for the apothem's length. And then take apothem and perimeter and plug it into the formula. Okay? How am I going to do that? Is this one of our special rights? Can I use Pythagorean's theorem? So, what? Trigonometry. We're going to have to use trigonometry. Okay, let's solve for half of our side length first. Now, you have 2 options. You can use half half of a side length, plug that in and solve for s if you want. Or you can represent it with some variable and say, okay, I know x is half of my side length, so when I'm done solving for x, I know I need to double that value to get one whole side length. That's up to you. It does not matter to me. But in the end, you're going to have to show work. Using what is printed or what you were given, using this, what trig function am I going to use? Solving for half the side length, solving for this side. Sine. Sine compares opposite divided by hypotenuse. Whenever you're solving for a side length, we're going to put the trig function over 1 and cross multiply. And we get that x is 5 sine of 25.7 degrees. Remember, x is half the side length. We've got to double that when we're done. Rounding to the nearest tenth. What is half of the side length? What? 1.5. No. What degree is your calculator in? Or what mode is your calculator in? It needs to be in degrees. Rounding to the nearest tenth, Crystal. 2.2. 2.2. And if we double that, about 4.4. So multiplying by 2 will get me my side, so s is equal to about 4.4. Cool? Let's solve for the apothegm. Let's solve for the apothegm now. Still using what we were given, the radius and the angle. What trig function are we going to use? Cosine, because that compares adjacent, and that's just a happy coincidence that the apothegm is the adjacent side to the angle that we find. We both begin with A. So adjacent, what's what we're searching for, and we know the radius. Use what you were given, printed. Okay. So cosine of this angle, 25.7, is equal to adjacent divided by the hypotenuse. Whenever you're solving for side lengths like this, put the trig function over 1 and cross multiply. You're going to get A is equal to 5 times the cosine of 25.7. Rounding to the nearest tenth, about 4.5. We're almost there. What's the next thing? Before that though. Yeah, you've got to find the perimeter. Got to find the perimeter. What am I going to do to find the perimeter? Okay, so we're going to multiply one side length, which is about 4.4. Times however many sides there are. In that case, this is 7, so 30.8. Okay, now let's plug it into the area formula and let's see what we get. Okay, and what do we get about the area?
69.3.
69.3. All right. Now, and what's it's difficult because they didn't give us a unit like centimeters, yards, inches, whatever. But make sure that you are getting in the habit of putting units. So if they don't give it to us, put U squared. Squared because it's area, 2 dimensions, so square. Now, you have to show your work because if you solve for S, like you plugged in 1/2 S, and you did that, you would have gotten that the side length was 4.3. and then your perimeter would have been 30.1. And so that would have you would have got very different answers if you did that. But if you would have shown your work, then that's fine. I know you didn't make a rounding error if you show your work, so it's imperative that you do that. Okay. This evening you are assigned 3 more of them, 15, 17, and 21 on that page. There's not much room, so you're going to have to do some of them on a scratch sheet of paper. And that's fine. You'll just write some of them on a side. What I did was I did evens on that piece of paper, and then I did the odds, like 15, 17, 21, on a separate sheet of paper, because I ran out of room. Now, problems like number 20. They don't give you a diagram. I'm not expecting you, number 20, to sit there on a quiz or a test, or even on homework, and try to perfectly draw a regular 18-sided polygon. That's ludicrous. I mean, that would take us hours to try to do that and make sure that all the sides were congruent and angles were congruent and it looked all pretty. Like you don't need to do that. You don't need to do that. The only reason you need to know the number of sides, which in this case, that's what number 20 says, right? Mm-hmm. Okay, cool. The only reason you need that is for the number of sides to find your central angle. You know that your central angle is always going to be created by 2 consecutive radii, and it's always going to open up to 1 side length. So this central angle, if you have 18 sides, is going to be 20 degrees, correct? So when you turn your focus and your attention to that right triangle we're trying to solve, you know that it's half of that central angle, so in this case it's 10 degrees. What were you given about this 18-sided polygon? Side length is what?
8 meters.
So what do you know about this special, or this right triangle?
Half of this is
What is it? What do you know about the right triangle?
half of this is
Wait, I'm not talking about 18, I'm sorry. I'm talking about number 20, right? Yeah, I've been talking about number 20 the entire time. Okay, good. And so we know that half of the side length is what? 4. What is it? 144 meters, right? They do give us a unit on this one, meters?
Yeah.
So what's the only thing we need to find on this example to get the area? It's the apothem. So this is what I was talking about earlier. Radius is not imperative. You don't need to know the radius length. So do not waste quiz and test time finding units and lengths that you don't need. Because every single quiz and test is time. And some of us are worried about not getting to all the questions. That's because you're wasting time on things you don't need to do. And when I hand this quiz back to you, we'll talk about some examples that were just time wasters that you chose to solve for, and it was unnecessary. It was totally unnecessary. So on this, you're not concerned about the radius. You only need the apothem to solve for the area of this regular polygon. How am I going to do that? Trigonometry. Which trig function? Tangent. So tangent of 10 degrees, because that's my angle, is equal to my opposite side, which is 4, divided by my adjacent side, which is my apothem. I'm going to cross multiply and divide, and I get that my apothem is 4 divided by the tangent of 10. Go ahead and do this on your own. Get a rounded answer for the apothem. Plug it into your area formula, and then check with your neighbor and see if y'all are getting the same answer.